right, so here we're at the second day of evaluating limits by using just our skills of plugging in as well as a little bit of algebra. Here we're going to talk about both radical, which is what you see here where we have square roots, and rational, which is where we have fractions. So make sure you got your stuff ready for notes and we're going to get started. So again, the first thing that you're always going to want to do is try to just plug the number in. Make sure that you're not getting a denominator of 0, which we're not here. We're going to get a denominator of 4. So one thing that you're going to do is you're going to start doing algebra right away. This is something I see in all of my calc students. If it's not going to equal 0 in the denominator and it's not going to be negative inside of the root, which we're not because we don't have any negatives going on, then we can just plug in. We can say, well, this is then 2 squared plus 9 minus 3 over 2 squared, which equals root 13 minus 3 over 4. And you can just evaluate like that. Now, of course, we are going to have very few that are just this nice, and we're going to have several where, oh, if I plug this in, 0 into the denominator, oh, that's our DNE, and we're going to have to find something else. Now, if you have a radical, you're going to want to multiply by the conjugate. You're probably used to thinking about this in terms of imaginary numbers, but it exists for any rational expression. So if you remember the conjugate, if we have something like a root plus another number, or that other number could just be 0, the conjugate is that same term but with the negatives changed. This is what makes it a conjugate. You're just changing the sign. And when you FOIL that all out, you get a minus b squared. And so the nice thing about that is you'll notice that there's no roots left. So in this case, that's going to be a good place to start. And the conjugate here that we're going to multiply by is the root x squared plus 9 and over x squared plus 9 inside the square root. And the sign that we're changing is this negative sign. Just change it to a positive there. And then our b term, 3. So then, once we multiply by the conjugate, we still get the limit as x approaches 0 of, when we FOIL out that numerator, we get x squared plus 9, because the root part disappears when you multiply them together, because you're squaring it, minus b squared, b is 3, so minus 9, all over x squared times that conjugate again. So root x squared plus 9 plus 3 in the denominator. Now, nice thing that happens here, plus 9 minus 9 cancels out. Oh, and we've got x squared over x squared cancels out. And we're left with our limit as x approaches 0 of 1 over root x squared plus 9 plus 3. And then when we plug in 0 to this formula, we're not going to end up with a denominator of 0. We're going to end up with root 0 plus 9 plus 3, all under 1, which is 1 over root 9 plus 3, which is 3 plus 3, which is 6. So that's how we're going to use our conjugates when we see radical equations, where the denominator equals 0. So the last thing is we might have rational, where we have things written as fractions here. And of course, we're going to have this error when I plug this in. We get a denominator of 0. So we're going to again look at algebra. Now, when we are subtracting fractions like this, we need to find a common denominator. Now, one thing that's helpful is you might be able to just jump to the common denominator at this point. If you can't, that's great. Just try factoring first. So here we have 1 over t minus 1 over t times t plus 1. The common denominator we want is t times t plus 1. Multiply by that on both sides for the other fraction, and then make it one large fraction over the common denominator. So that's t plus 1 from the first one minus 1, and it's the limit as t approaches 0, because obviously without that it's just equaling 0. These cancel. Oh, just like last time, now this cancels, and so we end up with lovely limit as t approaches 0 of 1 over t plus 1. And now when we plug in to the denominator, it's fine. We end up with 1 over 1, which is 1. Hopefully this feels pretty natural, pretty familiar from our algebra skills from last year and the year before. Please let me know if you have any questions on any of the homework in the forums, in the comments, or set up a tutoring appointment. Talk to you all later.